Welcome to CARICOMP Insider, where high-tech facial recognition meets real-world intelligence.
Every person on that video call, the CFO, the senior executives, the colleagues nodding along, was fake. Every single one was an AI deepfake. And the one real human on the line transferred $25 million. That happened to a finance worker at Arup, the global engineering firm. And the attack probably cost less than $10,000 to pull off. That's a return of roughly 2,500 to 1. Even if only 1 in 100 attempts like this succeeds, the math still overwhelmingly favors the attacker. Which means deepfake fraud isn't some rare, exotic threat. It's economically inevitable. So how did a single video call fool a trained professional, and what actually happened under the hood? The deepfake on that call wasn't one trick, it was 3 separate AI layers running at the same time. Layer 1 is facial mapping and reconstruction. Layer 2 is voice cloning with real-time audio synthesis. And Layer 3 is behavioral mimicry, lip sync, expression matching, the subtle stuff that makes a face feel alive. No single detection method catches all 3 at once. That's why it works. Start with the face. Deepfake generation begins by mapping 68 anatomical points across a target's face. Eyes, nose, mouth corners, jawline, hairline. Each one becomes a coordinate. Those 68 landmarks form a skeleton, and a neural network uses that skeleton to build a 3D reconstruction. It computes the pose of the face, both viewpoint and expression, then warps the source face onto the target. A separate network segments the face from the background, removing things like occlusions, glasses, a hand resting on a chin, a head tilted at a steep angle. Those still trip up the warping algorithm. Forensic examiners can sometimes catch inconsistencies at extreme angles, because the math behind that warping doesn't handle them cleanly. Now the voice. How much audio do you think an attacker needs to clone someone's voice? According to McAfee's research, just 3 seconds of audio produces an 85% voice match. 3 seconds. MIT researchers demonstrated high-quality speech generation from only 15 seconds of training data. Previous systems needed tens of hours. The Arup attackers didn't need to hack anything. They scraped LinkedIn videos, press conferences, and YouTube clips, all publicly available. So what about the live interaction? Wouldn't a deepfake stumble if the victim asked an unexpected question? This is where a common assumption falls apart. Current tools typically need about 30 minutes of processing to generate just a few sentences of video. That's nowhere near fast enough for a real-time back-and-forth conversation. The attackers almost certainly pre-generated a set of video clips, face, expressions, lip movements, all matched to cloned audio, and then played them back in sequence during the call. They controlled the timing. They controlled the script. It was staging, not some magical real-time AI conversation. And what about biological tells? The little signals a real face produces that a fake one doesn't. Research has shown that real video contains periodic eye blink patterns, while many deepfakes don't reproduce them accurately. Heart rate-linked skin color changes, micro-expressions, gaze direction, All of these can expose a fake under frame-by-frame analysis. But on a live call, in real time, with a stressed employee facing a high-pressure financial decision, those signals vanish into the noise. And that brings us to what actually happened. The finance worker noticed something was off. The CFO's face looked a little wrong. The employee had doubts, but then the other participants on the call, all of them deepfakes, confirmed the transaction. Authority, urgency, and social proof overrode what the employee's own eyes were telling them. The deepfake didn't win because it was perfect. It won because it was just convincing enough to delay skepticism for about 10 minutes. That's a much lower bar than most people imagine. People believe deepfakes must be nearly flawless to succeed because every headline calls them indistinguishable and hyper-realistic. But the real threshold isn't perfection. It's plausibility, just enough to keep someone from hanging up and calling back on a known number. So the takeaway is this. A deepfake video call layers fake faces, cloned voices, and scripted behavior all at once. It doesn't need to be perfect. It just needs to be good enough to stop you from double-checking through a separate channel. And the fix isn't training your eyes to spot fakes. It's adding friction, a callback to a known number, a confirmation over email, a second verification step that a pre-rendered video clip can't answer. Sometimes, slowing down is the strongest security measure you have. The full story's in the description if you want the deep dive.
Now you know something most people in this industry don't. Use it. And when you're ready to put it to work, caracomp.com. We'll see you tomorrow.